We want to first identify what form the equation has been written. And so noticing here that this only has one parenthesis in it, and that parenthesis quantity is being squared, this one is what we call our vertex form. So this is what we did on the first day. And the general form of that is a times the quantity x minus h squared plus k. So we want to recognize the form. Now what's really nice about vertex form, this is the easiest one to get the vertex because we don't have to do any sort of calculations. We're just looking at the numbers that have been given to us in the equation. So the x value of the vertex is going to be the opposite sign of the number that we see in the parenthesis with the x. So I saw that a lot of you got positive 3 for the x value. Great. When we get the y value of the vertex, that's k, that's the same number with the same sign as the number on the x. So I saw that a lot of you here got positive 10. Perfect. That one is done. Okay, we do have a little bit more work to do to get the vertex on the other two forms. So let's look at the one in the middle. Notice that this one has two parentheses. And so this is actually what we talked about on Tuesday. This is our intercept form because we very easily can get the x-intercept. That's why it's called that. So remember that our intercept forms generally look like this. And the P and the Q don't represent anything of the vertex, but those are the x-intercepts on the graph. And because of the minus signs in the formula, the x-intercepts are going to be the opposite sign of the numbers that we see here in our two sets of parentheses. So I'm just going to make a little note here. This is not my answer for the vertex, but I'm going to make a note that the x-intercepts occur at positive 4 and negative 2. Because we can actually use the x-intercepts to help us figure out our vertex. So not a full graph here, but just a really basic sketch. The idea is that the vertex is somewhere down here, and the x value of that vertex is exactly halfway between the x-intercepts. So that's how we use the x-intercepts to get started in finding our vertex. Now, if the numbers are easy enough or small enough for us to think about and work with, maybe thinking about this as a number line, I know that there's 6 spaces from negative 2 to 4. 1, 2, 3, 4, 5, 6. If I were to number them all, I can see, oh, I messed that up. I did an extra line. There we go. So negative 1, 0, 1, 2, 3, 4. I can see that the middle point is an x value of 1. So that's the x value of our vertex. Another thing that we talked about in class to get the x value of the vertex is to add the x-intercepts together and then just divide by 2. And so when we do that, notice how we get the same middle point of 1. Okay, so for my final answer of the vertex, so far all I know is the x value of 1. I still need to do some work to figure out what is the y value. Well, once we know the x value, all we have to do is take that value for x. We're going to plug it in for x into our equation back at the beginning, and then we're going to solve for y. So we're going to plug it back in up here at the very top. I'm going to erase some of this so we have some room. So when we plug it in here to get the y value of the vertex, we have the quantity 1 minus 4 times the quantity 1 plus 2. And then it's just all about order of operations. So we're going to simplify down within the parentheses first. 1 minus 4 is negative 3, and 1 plus 2 is positive 3. Notice how I still put those results in parentheses? They're being multiplied together. That's what it means when two parentheses are touching. So negative 3 times positive 3 is negative 9. So we plug in an x value of 1. The y value that we get is negative 9. So that is the answer for the vertex on the second one. All right, let's take a look at the last one. This one doesn't have any parentheses, and so this is what we call standard form. And generally, it's ax squared plus bx plus c. And so when we're dealing with standard form, it's always really nice at the start here to identify what's a, what's b, and what's c. Now, to get the x value of our vertex, we have a really simple formula that we want to memorize. It's negative b over 2a. We only do that formula if it's in standard form. So let's grab the values here. There is a negative sign in the formula. B is 6, and then a is 3. So this becomes negative 6 divided by positive 6. So we end up getting that the x value of our vertex is negative 1. Now it's kind of like what we just did with the middle problem. As soon as we know the x value of the vertex, we're just going to plug that in for x back in the original equation, and we're just going to solve it down for y. And when you plug it in, you just have to follow order of operations. So let's see how that would look for this one. So I'm going to say y equals, every time I plug in a negative 1 for x, I'm going to use parentheses. And this is going to help me be very careful with how we simplify this down. When we think about order of operations, we need to do operations inside of parentheses first. We actually don't have any operations inside of parentheses, like adding or subtracting, so we don't need to worry about that. But we do have an exponent. So that means that we need to do this negative 1 squared first before we multiply. What is negative 1 squared? Positive 1, right, it's just negative 1 times negative 1. Okay, so that's interesting here. Negative 1 squared was 1. Well, we're still going to multiply that by the 3 that we had in the very front. Okay, now in order of operations, now we can do all of our multiplication. We have 2 sets of that. Right here, 3 times 1 is 3. And then in the middle, 6 times negative 1 is negative 6. We don't have any division. When it comes time to adding and subtracting, we just go from left to right. So let's start by doing, what's 3 plus negative 6? Beautiful. And what's negative 3 plus 5? 2. Okay. What is the meaning of that 2 that we just got? What is that? That's the y value of the vertex. That's right. So we're going to go back up here. There's our answer for the vertex. So the 2 that we got when we plugged it in, that's the y value. There's nothing that you need to write down here, but this is just a paper that you could go back and reference. So I just want to remind you and be very clear about what A represents in your equation. We see that we have A at the very beginning of every single form, and it's the same A for all the forms. And so the way that that affects the graph of the parabola is it tells us the shape of it. How wide is it going to be? Is it going to be skinny and narrow? Is it going to be really wide like this, or is it just going to be regular? The regular one is what I think about when A is 1, or if it's flipped over, that's when A is negative 1. And so from the vertex, we're going to count over 1 space on either side. I'm going to go over 1 space on either side, and notice that when A is 1, we're going up 1 space on either side. Over 1, up 1. Now, the other thing that's nice to do with this original one when A is 1, the next set of points from the vertex is over 2, up 4. All right, so it's either opening up if it's positive, or it's opening down if it's negative. This one is probably the most common. But it's possible that you have a different number for A. So in the next picture here, in the next row, if A is 2, the only thing that changes here is that when you go over 1 space on either side, instead of going up 1 space, It's actually going up 2 spaces. And that's why it's getting like skinnier and narrower. That's why it's vertically stretched if you have a 2 in front. It's the exact same pattern of points. If it's a -2, it's just flipped upside down. We're just going to look at one more, but we could do a lot of these. But the last one we have down here is, well, what if A is 3? 3 is bigger than 2, so it's going to be stretched out even more. So look at this. From the vertex, when you go over 1 space on either side, now you just go up 3 on both sides if A is 3. So the number that we're going up is equal to whatever that A value is. So again, this is just a page for you to reference, to think about how it's going to look a little different on the graph based on what your A value is. So you have all the tools to graph any quadratic function. You can make any parabola because you can find the vertex, all the different methods on the front side, and then you can use A to figure out, is it opening up, is it opening down, and what's the shape? How wide is it, or how narrow is it? All right, folks, so we are not talking about parabolas today. We are not talking about the vertex point. We're not graphing. Today we're actually switching gears. So we are going to be taking a look at factoring. Factoring is a super important piece of algebra. This is actually kind of like the multiplication facts that you learn in grade school. Once you learn factoring, it never goes away. It's something that we're going to continue to use for the rest of the year. Depending on the math class that you sign up for next year, you may continue to use it all throughout the next class, and then all throughout the next class after that, and so on. So this is a super important day. We are going to be looking at expressions that are quadratic expressions. Quadratic because they're all going to have an x squared. So the x squared part should look familiar. If you take a look over here on the side board, we have a lot of different situations that we're going to look at. So we're going to use a variety of methods, including looking at basic trinomials, other trinomials, greatest common factor, difference of squares, and perfect square trinomials. Okay, so we are going to begin here. So it says part 1 at the top. This is really just the first part of our lesson, and then part 2 is going to be the second part. So we're going to actually begin by multiplying something out that should look familiar to us. So we have 2 quantities in parentheses side by side. We've actually seen problems like this in the last few lessons. And so remember that we have 2 ways that you can multiply this out. So you can multiply this out with FOIL, or you can multiply this out with the box method. If we were to use FOIL, we're going to begin by multiplying the first term times the first term. So that's actually going to be x times x, but we'll simplify that to be x squared. Then we're going to do the outside term together, so that's going to be the x at the very beginning multiplied by the 4 at the very end. X times 4, we would actually put the 4 in front, so we're going to write that as 4x. All right, the I stands for the inside terms. When we multiply the inside terms together, we have 3 times x, and we will just write that as 3x. No need to put the little multiplication dot. And then for the L, that is the last term times the last term, 3 times 4, and that ends up being 12. Notice how the steps in FOIL, it's really just the distributive property. That's all it is. So we're just going to distribute the first x to both parts in the second parenthesis, and then we're going to distribute the 3 to both parts in the second parenthesis. Now then what we want to do is write this out and combine like terms. So initially, all of these terms are positive, so we are going to put plus signs in between them. Then we're going to look for like terms. So 4x plus 3x, altogether that is 7x. In order for us to put like terms together, the variable part has to be exactly the same, and then we just add the numbers in front and we keep the variable the same. All right, here's how we would do the box method. So we're going to write one of our parenthesis factors on the top, x plus 3, and then we'll do the other parenthesis factor on the side, and that would look like this, x plus 4. It is helpful on the box method to transfer over either the plus sign or the minus sign that you see. Now, we're just multiplying each little square. So in the top square, this is x times x, so we get x squared. Over here, this is 3 times x, so we get 3x. Down here, 4 times x is 4x. And then finally, 4 times 3 is 12. So notice how we have exactly the same four pieces. X squared plus 4x plus 3x plus 12. So we could extract them out from the box, write them out like this, and combine like terms. Okay, so what if we wanted to go the other way around? So let's say that we started with x squared plus 7x plus 12, and we wanted to turn it back into x plus 3 times x plus 4. Would you talk at your tables here for just a moment? Do you notice anything about the connection between the numbers? How are 7 and 12 related to the numbers 3 and 4? All right, so let's just notice that here. So 3 plus 4 was equal to 7. 3 times 4 was equal to 12. So if we wanted to go the other way around and we wanted to figure out how to fill in the parentheses, we would need to find two numbers that multiply to 12. It's always going to multiply to the number at the end. And at the same time, we want them to add to 7. They're going to add to the number in the middle. And going that other direction is called factoring. So we know how to multiply, that's going forward. Factoring is what we do when we're going backwards. So let's take a look here at a few more examples. In general, when we talk about factoring trinomials, we want to kind of think of this similar to what we did here with the standard form, where we have A, B, and C. If A is 1, this is what we call a basic trinomial. And so if A is 1, there's like an invisible 1 here in front of the x squared. Really, it's just x squared plus bx plus c. So writing this out in a slightly different way, we're always going to try to find two numbers that add to b, so it's always adding to the value in the middle, and multiply to c. It's going to multiply to the number at the end. So let's try this. Here we have x squared plus 14x plus 40. One thing that I like to do to organize my thinking is draw an x diagram. So for this one, I'm going to always put the number that it multiplies to on the top. So I'm thinking to myself, I need to find two numbers that multiply to 40. And then whatever number it adds up to, I'm always going to put that on the bottom. Two numbers that add to 14, at the same time, they multiply to 40. Can anyone think of two numbers here that meet both requirements? What do we get, Sheila? 10 and 4. The order that we write them does not matter, so the position you put them in, but once I find my two special numbers, that's what I call them, the special numbers, I'm going to put them on the side. And I also like to circle them, because these are the numbers that are then going to go into my answer. They're going to go into our parentheses. So basic trinomials always factor into two parentheses side by side. So let's start with that. We always have an x out here in the front of each one. Now, if this is a positive 10, I'm going to put a plus sign in front of 10. If the 4 is also positive, we're going to do a plus sign in front of the 4. So it looks like this. We have the quantity in parentheses, x plus 10, multiplied by the other quantity, x plus 4. And that's it. You can always check your answer here by multiplying it out. You can multiply it out of FOIL. You can multiply it out of the box. Make sure that it equals the same thing that you started with. Now, sometimes we have values in here that are negative. And so let's take a look here at the next one. Here we need two numbers that multiply to 30, but now we want them to add to negative 11. I'm going to give everybody a quiet moment here to think about the numbers. If you have identified the two special numbers, I want you to write them on your paper on the left side and the right side. Now at your desk, if you've thought of two numbers that could work, I want you to put your thumb up in front of you. Okay, Megan, what do you get? Awesome. And so in this case, it makes sense that they're both negative because -6 plus -5, that's -11. But when we multiply a negative by a negative, it equals a positive. So when we multiply them, it's going to equal +30. All right, so let's fill this in here. Very simple. Two parentheses side by side. We have x minus 6 times x minus 5. All right, let's try this next one. We have a negative showing up again. Now we want our number to multiply to -15. And we want them to add to +2. So take a moment here on your own. Think of the numbers. Write them down. Thumbs up if you thought of something. Josie, what'd you get? Nice. Okay, so here we had one value that was negative, one was positive. That makes sense here because opposite signs multiply together to equal a negative. When we add them, though, -3 plus 5, that turns it into +2. So sometimes they're opposite sides. So let's go ahead and fill those in our parentheses, x minus 3 multiplied by the quantity x plus 5. Now here's the thing we need to know about that method we just learned. In order for us to use that method, the number out in the very front, the a value, has to be +1. Sometimes there's a different number in front. And so let's take a look at this sentence. Sometimes we have to divide everything first by a. And what we do is we keep that original a in the very front of our final answer. So it's like a number out in the front of two parentheses. So here's what that looks like. Let's look at 5x squared plus 5x minus 10. I don't want this 5 in front of the x squared right there, because I can't use the method. And so to divide everything by 5, that looks like this. Every single little piece gets divided by 5. Now, I'm going to take that 5 that I divided everything by, and initially, it does not go away. We are just repositioning it. It's going to be written out here at the very front of one big parenthesis. The in-between step is I'm going to write the results of dividing by 5 in the big parentheses. So I'm not ready to go to two parentheses yet. I have to see what happened when I divided by 5. So what's 5x squared divided by 5? What's 5x divided by 5? It's 1x. What's -10 divided by 5? -2. Okay, so that's the result of dividing by 5. Now, keep the 5 in front. We're just going to keep it in the final answer, but we're done with it right now. Everything that you see here in orange, that is a basic trinomial. So now we are going to go ahead and do this for the basic trinomial on the inside. We want to figure out what multiplies to -2 and adds to +1. Well, I know if it's going to multiply to 2, it's got to be 1 times 2, the only option. But to make it negative, one of these has to be negative. I'm going to make the -1 negative, the 1 negative, said negative too many times. I'm going to make the 1 negative because -1 plus 2 equals the +1 at the bottom. So now we're going to get our two parentheses side by side. We've got x minus 1 we've got x plus 2. Notice how we keep the 5 in the front. So that right there is our final answer. Yes, Sheila. Let's look at this sentence here at the bottom. If every term can be divided by the same number, that special number that we divided everything by is actually called the greatest common factor. There's a 5 right here. If we were to just make a little note for that, that 5 is a GCF. That stands for greatest common factor because we divided everything by it. Your greatest common factor always is in the very front of your final answer. Okay, let's look at one other example here, because what's interesting about this one is the number that's in front of the x squared is actually -1. It's just a negative sign. We could write in the little 1 here so that we can see it like it's an invisible -1. And so we have to divide that out before we can use our method, because remember that to use our method it has to be a positive one, but right now it's not positive, it's negative. So it's going to be just like what we did with the 5, except now every single piece is divided by -1. Now that -1 is the greatest common factor. Greatest common factor is always written out here at the very front. What's -x squared divided by -1? And then what's 7x divided by -1? And how about 18 divided by -1? Awesome. All right. Now we want two numbers that multiply to -18 and add to -7. So that could work here if we do -9 and +2. So that's just going to be this part. So first parenthesis, x minus 9, second parenthesis, x plus 2. Notice how we are going to keep the greatest common factor of -1, keep that out in the very front of our answer. Sometimes we have a trinomial when a is not 1, and we cannot use the method that we just did. It cannot be factored out as the greatest common factor. So let's look at this one, 2x squared plus 5x plus 3. I can't do what I did before, because even though the first one divides by 2, I can't do 5 divided by 2 evenly. I don't want to deal with fractions. I can't do 3 divided by 2. So 2 is actually not a greatest common factor. If you don't have something that you can divide everything by, you actually don't have a greatest common factor. And that's fine. We don't always have one. And so instead, we have some other ways that we can think about solving this. So I want to actually show you two ways. The first option here is the guess and check method. So this is where we know our answer is going to end up being 2 parentheses side by side. And we're going to think about FOIL to kind of work backwards and figure out what the pieces are. So, for example, when we're doing FOIL, the first term times the first term has to equal 2x squared. Well, there's actually only one possibility for what that could be. We could have 2x in one parenthesis, and then just a regular x in the other parenthesis. Because 2x times x, that's the only way that we would end up getting 2x squared. Because the 2 is going to stay in front, and then x times x is x squared. Now the next thing we want to look at is the last term multiplied by the last term. Well, I can see here in the problem that that is going to end up being 3. Hold on, I want to change to a different color. The last term times the last term has to be 3. Well, there's only one way that that can happen, if it's 1 times 3. Now here's where the guess and check comes in. Where do we put the 1 and where do we put the 3? Here we have two options. Here are the two options. You could put the plus 1 in the first parenthesis and the plus 3 in the second parenthesis, because 1 times 3 is 3. Or maybe it's the other way around. Maybe it's the 3 in the first one and it's the 1 in the second one. We have two options. So here, we're going to check it. We can think about the middle part of FOIL. What it's going to come down to is what is the outside term and what is the inside term. Because the outside term and the inside term has to add to be 5x. And only one of these options is going to do that for us. So if we look at the first option, the outside term, 2x times 3 is 6x. The inside term is 1x. What's 6x plus 1x? 7x. So that actually gives us a 7x in the middle. So that is actually not right. That doesn't work. We don't have 7x in the middle. Let's double check and test the other idea. When we do the outside term, 2x times 1 is 2x. The inside term is 3 times x. What's 2x plus 3x? That is 5x. That one works, because that's what we wanted it to be. And so this is going to be our final answer through guess and check, 2x plus 3 multiplied by the quantity x plus 1. And you can always FOIL this out to get this to work. Oh, thank you. Where open the yellow? Yes. Okay, so here's the thing. Sometimes the guess and check is too hard, or it is so much work based on the size of the numbers, based on how many possibilities there are. Like this one was not bad. We only had 2 options to check. But there are other situations where you might have to test 6 options. You might have to test 8 options. Well, let me give you another method. Let me show you another idea that's going to help save you some time. I don't mind guess and check when the numbers are small and there's not many things to check. But if the numbers get a little larger, I like another method instead. And so I want to teach that to you now. It's very fun. It's very easy. It is called the slip and slide method. And what I want to show you here is we have exactly the same problem that we did with guess and check, so we know what the answer should be. I want to show you another way to get that. So step 1 of slip and slide is to double check to make sure that A is not a greatest common factor. Slip and slide actually does not work if A is a greatest common factor. So keep that in mind. I already know it's not from what I saw before, because if I try to divide everything by 2, I get stuck very quickly. Okay, so it's not a GCF. All right, so here's the first step of slip and slide. We are going to slip the A value to the end of the trinomial and multiply by C. And so what I'm going to do here is draw an arrow. A is 2, C is 3. We're going to do 2 multiplied by the 3 at the end, and that's going to make a new trinomial. So the 2 slips to the end, so it's not at the beginning anymore. It turns into x squared plus 5x plus 6. And if it's helpful, you could even write the word multiply inside of that little arrow. So we're going to multiply 2 times 3 to get 6. Guess what we turn it into? Now it's basic. It's a basic trinomial, because now we don't have anything in front of x squared. We're going to factor the new basic trinomial. Now in this case, we need to find what multiplies to 6 and what adds to 5. What could we do for our 2 numbers? What have we got, Jack? Read 2. All right. So we've got x plus 3 times x plus 2. Now we're not done yet, because if we multiply this with FOIL, it does not equal what we started with. It equals the in-between step. So we're not done. Let's go over here and look at step 4. So once we factor the basic trinomial, now we're going to divide both factors, which means the numbers in the parentheses with the x, we're going to divide them by the number that we flipped over in part 1. So remember how we multiplied over that 2 at the very beginning? Well, now to undo that we multiplied by the 2, we are going to divide it out of both parts. So here's what that looks like. Just like this. I'm going to highlight what I just wrote. So that 3 in there divides by 2, and then over there the 2 divides by 2. Okay, so that is step 4. Now, final step here is we're going to reduce the fractions and then slide any denominators up next to the variable. So let's look at the fractions we have here. That 3 over 2, is that a fraction that can be reduced any further? No. And so what we're going to do then is slide the denominator, so that's the little 2 down here, that's going to slide over here and it's going to go in front of the x. So there's our first parentheses, 2x plus 3. Now let's look at the second fraction. That is 2 over 2. Can that be reduced? Yeah, what does it turn into, Riley? 1. Sometimes it reduces down to a whole number. Well, if it does, we just leave it. We just leave it as it is. Whoops. And that is our final answer. And we can check here that if we were to actually FOIL this out, 2x times x is 2x squared. 2x times 1 is 2x. 3 times x is 3x. And 3 times 1 is 3. And that's the same thing that we started with at the very beginning. Also, 2x plus 3 times x plus 1, that's the same answer we got when we did the guess and check. So that is how we do the flip inside. Here. So on this next one, so the first step is to always multiply over. So we're going to multiply the first number that we call a. We're going to multiply that by the number at the very end that we call c. So 6 times negative 4 is negative 24. So the negative 24 at the end here is from multiplying the number at the beginning by the number at the end. So here, everything else just drops down. So now we have a basic trinomial, x squared minus 5x minus 24. All right, now we want to find what multiplies to negative 24 and at the same time adds to negative 5. So I would do negative 8 and positive 3. By the way, sometimes this is a place where students get stuck because it can be hard to figure out what are the special numbers. And so something that you could do is you could think of all the factors of 24. And so you can make a list off to the side. So I can say, okay, well, I know that I could do 1 times 24, I could do 2 times 12, I could do 3 times 8, or I could actually do 4 times 6. 24 actually has a lot of factors, a lot of numbers that multiply up to it. Well then, knowing that one value has to be positive and one value has to be negative, I know that. I want it to add up to negative 5, so I'm going to try to find an option that's 5 away. So like 1 and 24 would not be good because those are 23 away on the number line. 8 and 3 would work because those are 5 spaces away. And I wanted it to add to negative 5. So I'm going to attach the negative sign onto the 8. I'm going to keep the 3 positive so that it works out. You can also use a calculator to help you come up with a list. If you don't know what the factors are of 24, start with 24 in your calculator and just try dividing it by everything. Divide it by 2, see what happens. Divide by 3, divide by 4, see what you get. That can help you to generate a list. Okay, so once we factor the basic trinomial, now we're going to divide our numbers here by the a value that we multiplied over in the very beginning. So here we are dividing both pieces by 6. Well, now I have a fraction that I could simplify, 8 over 6. 3 over 6 we can also simplify. So do not move the 6 up in front of the x yet, because the fractions have to be simplified down. What can we reduce 8 over 6 into? You think of how I could simplify? Or is there something that you could divide 8 by that you could also divide 6 by? 2, because they're both even. 4/3. Beautiful. Okay, let's do the same thing over here for 3 over 6. What do we get when we simplify that down? Or what could we divide the top and bottom by? Yep, we could divide the top and bottom by 3, so that's going to turn into 1/2. So make sure that we have our fractions simplified. Now, we can go ahead and take our denominators. We're going to slide those back in front of the x. So final answer here, we have 3x minus 4. In the second one there, we have 2x plus 2x plus 1. And you can always, at the end here, check your answer with FOIL. One other quick thing I want to say about the last problem on this page is about the situation of there being a greatest common factor. So remember we said that the slip and slide method does not work if there is a greatest common factor. And so when we take a look here at the problem at the end, I can see that that 12 in front of the x squared, I actually can't divide everything by 12 because the problem is in the middle. 10 does not divide by 12 evenly, so that doesn't work. So I'm not going to be able to get rid of the 12 altogether. But does anybody see another number that you could divide all the pieces by? What do you notice, Evan? Yeah, they're all even numbers. We could actually divide everything by 2. So sometimes there is a greatest common factor. That's not the a value, it's not 12, but it is something else. So that 2 is still going to stay in the very front of our final answer. When we divide everything by 2, then we get 6x squared plus 5x minus 6. Now we can do the slip and slide method for just the inside part. Now it'll work. You just keep the 2 at the very front of the beginning. Okay, so we actually have 3 more methods, but these are quicker than what we just did. Actually, the very next one that we're going to do is going to feel familiar. It's also going to feel a little bit easier because this is just the greatest common factor method. And you'll notice that instead of having 3 terms, by the way, trinomial means that there's 3 pieces to it. So this is a trinomial because there's 3 terms. Well, what we're going to look at now, the greatest common factor, are expressions here that just have 2 terms. That's okay. They're still quadratic. Well, actually, these 2 are quadratic because they have an x squared. This one is actually linear because it's x to the first power. So the greatest common factor is just finding what everything can be divided by. And then we always put the greatest common factor out in front. So let's take a look here at 3x plus 6. Notice that they can both be divided by 3. So all we're going to do here is divide both parts by 3. The 3 goes in the front of the parentheses, and the result of the division goes in the parentheses. So 3x divided by 3 is 1x. 6 divided by 3 is 2. Now, when you check your answer for something like this, we're not doing FOIL because we do not have 2 parentheses side by side. We're doing the distributive property to check our answer. 3 times x is 3x, check. 3 times 2 is 6, double check. It's good. In the second one, sometimes the greatest common factor is not a number. Sometimes it's a variable. In this case, x squared, that really means x times x. This over here is 9 times x. So actually, the factor that they have in common, that they're both multiplying by, is the variable x. And so that's how this one is a little bit different. So we're going to actually divide both of these by x, and then we have x out in the very front of our parentheses. Well, if we have x squared and we divide out an x, we just have one x left. 9x divided by x is 9. In the last problem, sometimes the greatest common factor involves a number, and it also involves a variable. So what we see on this one, between the 2 and the 10, is they both have a 2 in common. But if you look at the variable part, they also both have an x in common. So on this one, we're actually dividing both parts by 2x. That's okay. The greatest common factor is 2x. You're going to put that in front. All we're left with from the first part is just a single x. We'll bring down a minus sign, and then 10x divided by 2x. The x's go away. That just gets divided out. We're really just thinking about here doing 10 divided by 2, which is 5. The other thing to know about the greatest common factor, so we already had a chance to see that a little bit with our trinomials. This is always actually something that we want to do first before we try any other methods. So always think for looking for a GCF. Okay, now we have a quick little intro here to our next method. So we have a few situations here that now we can multiply with FOIL because we have two parentheses side by side. What I want you to notice, though, is that every one of these, there's a plus sign in one of the parentheses. We have a minus sign in the other. Notice how it's the same number. X plus 1, x minus 1. X plus 2, x minus 2. Let's see what would happen if we multiply these out with FOIL. So this is what we get on the first one. What happens here in the middle? Minus 1x plus 1x. They're going to cancel each other out. It's going to turn into 0. So all we have is x squared minus 1. Really different looking answer here. We don't get a trinomial. We don't have that x term in the middle. We only have that term from the front and then the term from the very end. Well, if we do that for the next one, the same thing is going to happen. So now we have minus 2x plus 2x. We cancel out. We just have x squared minus 4. Okay, the last term times the last term is positive 2 times negative 2. Gives us negative 4. Let's look at the next one. Now when we do the last term times the last term, positive 3 times negative 3 is negative 9. And look, the terms in the middle cancel again. So we get x squared minus 9. So these have a special name. The answers we have here at the end, we call it a difference, because difference is the word that you use when you're subtracting. And what we're taking the difference of is two perfect squares. X squared is a perfect square. 9 is also a perfect square number. 4 is a perfect square number. 1 is a perfect square number. So this is called the difference of squares. So if you see something that looks like this, x squared minus 100, they're being subtracted. They're both perfect square numbers. It's going to factor into a special format. Two parentheses side by side, one is addition, one is subtraction. The number in the front of the parentheses is the square root of the first term. The number at the end of the parentheses is the square root of the second term. So these are very simple. Let's take a look at a few together. So x squared minus 100. Two parentheses side by side. 1 plus, 1 minus. We're going to square root the first term, and we're going to list it first. Then we're just going to square root the second term, and we're going to list it second. The square root of 100 is 10. And that's it. X plus 10 times x minus 10. Let's look at another one. Let's say you have x squared minus 4. Difference of squares. Two parentheses side by side, 1 plus and 1 minus. Square root of the first term is first. Square root of the second term goes second. The square root of 4 is 2. On your paper, I want you to try the next one. I want you to do x squared minus 25. We still have 1 plus, 1 minus. Square root of the first term goes first. That's x. Square root of the second term goes second. By the way, in the next one, the square root of 1 is 1. So just know if you see that, it's just a 1 there. Actually, that was one that we looked at when we were FOILing. So if there's no middle term, that's when you have 1 plus sign and 1 minus sign. Okay, sometimes you have a difference of squares that has a square number in front of the x squared part. That's not a problem. We're just going to take the square root of that piece as well. So if you have something like 9x squared minus 16, still going to set it up the same way. 1 plus and 1 minus. Now the square root of the first term is doing the square root of 9, which is 3, and we're doing the square root of x squared, which is x. So actually the square root of 9x squared is 3x. Then the square root of 16 is 4. It's pretty similar. This looks a little bit different. We get 3x plus 4 times 3x minus 4. This one is going to begin with a quick introduction using FOIL as well. So remember that when we have a quantity that is being squared, that means that it's being multiplied by itself. So x plus 5 squared, don't do x squared plus 5 squared. It doesn't work that way. It's x plus 5 times x plus 5. We're multiplying it by itself. Now when we FOIL this, there's something I want you to notice. The signs here, they're not different signs. They're the same sign. So it's kind of opposite of what we just did. The middle terms do not cancel because they're both positive. So if we were to combine them, positive 5 plus positive 5, that's positive 10. So it's x squared plus 10x plus 25. This is called a perfect square trinomial. It's a trinomial because now we have 3 terms, 1, 2, 3, and it was the result of a quantity in parentheses that was being squared. It's like a perfect square parentheses equals that. And so when we are factoring these, they are also very simple. There is one small difference from what we just did with our difference of squares. So here's how we can identify. If the first term is a perfect square, and the last term is a perfect square. That's all I want you to focus on here. So x squared is a perfect square, 81 is a perfect square. So it's still going to factor into two parentheses side by side. We're still going to, wait, no, let's not do that. Hold on. Okay, two parentheses side by side. Because we have the middle term, we're going to look at the sign of the middle term, see how it's a plus sign? That tells us that both parentheses are going to be plus signs. Because remember up here we saw that those weren't different signs, they're the same sign. And the sign is whatever you see in front of the middle term. Now, pretty similar actually to what we just did. We're going to square root the first term. Square root of x squared is x, so we're going to list that first. And then we're going to square root the last term. The square root of 81 is 9. It's kind of like the difference of squares, except they're both plus signs. Let's try this one. Notice how the middle term is minus. So that just means now they're both minus signs. We're going to square root the first term. We have to do the square root of 4 and the square root of x squared. So it's 2x. And then we're going to square root the last term. That's 5. I want you to try the very last one on this.